This video I am going to explain the setup spindle task. I hesitated a long time before implementing this. I was concerned about safety. Once I realized that the spindle wouldn't turn if the safety guard wasn't down and the lathe not powered on, I decided to implement this function. Grbl doesn't support G96 G-codes for constant surface speed. Therefore, constant surface speed is implemented using feed and speed overrides. As you can see, it is working pretty well. Most Grbl controllers have a 200% override limit. I modified Grbl L Mega to accept a 1000% override limit. Before we can use spindle speed control, we have to set up Grbl, set up the spindle and make some calibration curves. We start by setting up Grbl, so we select the setup Grbl task. In Grbl we have to set the minimum and maximum RPM. My spindle runs at 1850 max, but I set a more convenient value, 2000. Now Grbl is set up, we can select the setup spindle task. This text box shows if the actual spindle RPM is reported by your controller. If so, the actual spindle RPM is shown in the top right corner of the screen. If the actual RPM is reported, auto calibrate is enabled and you can get the actual RPM and set it in the database by pressing a button. Using the spindle on-off button, you can switch your spindle on or off. When set to on, the RPM value in this text box is sent to the controller. Using the spin-up time, you can slow down the acceleration of your spindle. That is better for bearings, belts and gears. If you want to use the constant surface speed mode in the facing task, the app has to know when to start a new pass. For that, it needs to know the spin-up time and the spin-down time. My lathe has a brushed DC motor that spins down pretty slow. Constant surface speed mode in the facing and parting tasks are implemented using the feed and speed override functions of the controller. Most controllers have a default value of 200%. I modified the Grbl L Mega firmware to accept a max override of 1000%. This controller is automatically recognized by the application. You have to set the correct value, otherwise constant surface speed in parting and facing task will not function properly. To prevent setting a wrong RPM, you can set the minimum and maximum RPM of your spindle. When I press the setup button, these values are evenly spread between the 20 calibration points. That gives some weird values and I don't like that. So I set the minimum value to 0, the maximum value to 2000 and press the setter button. Now I get a nice range. And then I can set the correct values. If a single pass or multi-pass is started, it is checked whether the spindle is running within tolerance. When the spindle is running out of tolerance, you get a pop-up screen that allows you to stop or continue. If you set the tolerance to 0, then there is no check. To use spindle control, you have to set the mode to CNC. This is a global setting. You can disable this in a task by selecting a manual gear for that task. There are 4 calibration curves. Forward 1, reverse 1, forward 2 and reverse 2. Every curve has 20 calibration points. You only need to calibrate the gears you actually use. So let's start calibrating the first gear F1. When I press the Set RPM button, the RPM set point 700 will be sent to the controller. In the top right corner you can see the actual RPM is 81. So I can enter this value as calibration point. When I set the next RPM, 800, you see the actual RPM is 205. I could enter that manually, or I press the Get RPM button, and it is done for me. If your spindle doesn't report the actual RPM, you have to enter all the values manually. My spindle starts turning at a RPM set point of about 660. To increase the accuracy in the lower RPM range, I change the lower RPM set points. To auto-calibrate, the spindle must be off, so I start by switching the spindle off. When I press the auto-calibrate button, the first RPM set point is sent to the controller. Then the spin-up time of 5 seconds is awaited. The actual RPM is read and set as calibration point. Then the next calibration point is selected. The active calibration point is shown by the blue border and the calibration number on the right. It takes less than 2 minutes to measure a calibration curve. To measure the repeatability, I select the R1 gear. I keep the lathe in forward 1 gear, so when I auto-calibrate again, I should find the same results. As you see, the results are pretty close. When I turn the spindle on to run at 500 RPM, a set point of 1023 is sent to the controller. The actual RPM is 499. And I change the value to 1000. The RPM set point of 1375 is sent to the controller. That results in a RPM of 1000. 1500. set point is 1701 and the actual RPM is 1503. So setting the RPM is pretty accurate. I set the lathe in reverse 1 gear and measure the calibration curve. As you can see, at the same RPM set point, there is a big difference in the actual RPM. The spindle setup is now completed. So we can now use spindle speed control. We start by selecting the facing task. Press the S button to get in the task setup screen. Select the forward 1 gear. Leave the speed mode to RPM and the feed mode to feed slider. And press Done. Set the RPM to 400 and the feed rate to 40 mm a minute. When I press the start button, facing should start with 400 RPM and 40 mm a minute feed rate. Select the task setup screen. Set the speed mode to speed and the feed mode to feed set point. Then press Done. I set the speed to 90 meters a minute. That is recommended for this cutting tool. I set a feed rate of 120 mm a minute. Then press the start button. Select the setup screen and activate constant surface speed. Set the feed mode to feet per revolution. Then press Done. When I press the start button, facing will start at a speed of 90 meters a minute. To maintain that speed, the RPM will be increased when the diameter gets smaller. To maintain the feed of 0.1 millimeters a minute, the feed rate will be increased when the RPM is increased. Let's see how this works. In general, to get repeatable results, I run the spindle in speed mode and the feed in feet per revolution mode. To use spindle speed control, you have to connect the CNC controller's spindle speed output to your lathe spindle speed controller input. Most CNC controllers output a PWM signal. That is a pulse width modulated signal. Most of my controllers accept a PWM signal. My lathe, however, needs a 0 to 10 volts analog signal. I use this cheap $3 PWM to voltage converter. It will convert the PWM signal to an adjustable 0 to 10 volt analog output signal. Some speed controllers can't be controlled using an external signal. If this controller has an external potmeter, then you could use a small servo to turn this potmeter. I made such a CNC controlled potmeter using a small microprocessor board, a display and a rotary knob. I will explain this in an upcoming video. Thank you for watching.